Okay, so we're going to do one of the ICAS tests, and this is a very good preparation for the GATE assessment, the math component. So let's start. Question 1, here's a picture of a tennis ball. Which word best describes the shape of a ball? Okay, so I just want everyone to know that there are obviously 2D shapes and there are 3D shapes, okay? There are 2D shapes and there are 3D shapes. So 2D shapes, the technical word for a 2D shape is a polygon, all right? And the technical word for a 3D shape is polyhedron. So those are the words that we use for 2D and 3D shapes. Now, obviously, if you consider a tennis ball to be 2D, if we consider a tennis ball to be 2D, I guess it is a circle. But we know the tennis ball is not a two-dimensional object. We know the tennis ball is a three-dimensional object, and the three-dimensional version of a circle, basically, or the shape of a tennis ball, which is the answer to this question, is that it is a sphere. So the answer is D. Alrighty. We should all know what the other things, by the way, are as well. So if I was to discuss what the other options are, a cube is basically, if I was to describe a cube to you, so option A, which says cube, is think of it as, it's basically like the two-dimensional version of a square, but it's 3D, so it goes in every single dimension. And specifically, if they say the word cube, it means all the sides, the length, the width, the height. I'm going to call them all x, but they're all the same. The length, the width, and the height are all x, and that's what makes it a cube. All right, we all should know what a cylinder is. I'll try my best to draw a cylinder. So basically, it looks like this. Think of it like as a can, okay? And then there's like a circle on the bottom as well, okay? That's, if the best way I can draw a cylinder is draw a circle on the top, draw a circle on the bottom, and then connect it all up, and we've got ourselves a cylinder. Okay, think of it as like a can. And option C was prism. Now, prism basically means that it's got a uniform cross-section, okay? Uniform means same. It's got a same cross-section. So what I mean by that is this is an example of a prism. So for example, this would be a triangular prism. You can see that it has a triangular base, and then it just extends onwards for a particular depth, okay? So this is a triangular prism. You can have a rectangular prism. A rectangular prism looks like this. So there's a rectangle, all right, and then that carries on for a reasonable distance, okay? So there are different types of prisms. You have triangular prism if the base is a triangle. You have a rectangular prism if the base is a rectangle, etc., etc. Even this, even a cylinder counts as being a prism. We call it a circular prism. Even a cube counts as a prism. We count it as a square prism. So different types of prisms that we have. All right, question 2. Tessa is measuring the area of a local football field. What measurement unit should she use? Okay, so you'll notice that we have related answers. We have meters and we have square meters, and we have centimeters and we have cubic centimeters. Okay, so here's the deal. If you are measuring length, if you are measuring length, okay, so the units that we use for length are things like centimeters, meters, kilometers. Those are the units that we use to measure length. All right, and when I say length, length can include the perimeter of an object, okay? The length can include the perimeter. The perimeter is basically the outside area of any particular shape, okay? Not the outside area, sorry, the outside length of any shape. Then we have area of a shape. And when we have area, we use things like centimeters squared, meters squared, kilometers squared. Later on in the year, we'll even learn this thing called hectares. So these are the different ways of measuring area. All right, these are the metric units of measuring area. All right, and lucky last, we have volume. And the metric ways of measuring volume are like centimeters cubed, meters cubed, kilometers cubed, all right, etc., etc., okay? And in fact, there are smaller units than centimeters. There's like millimeters as well. I mean, there's even nanometers and picometers and also and micrometers, all sorts of things. But you can also use millimeters squared if you're dealing with really small things. Millimeters squared, same thing with volume. You can deal with millimeters cubed. So there's different units, but you'll notice that if it's length or perimeter, there's no squared or cubed. However, as soon as you use the measuring areas, areas will always be something squared. All right, except for hectares, okay? Hectares is where they don't use the word squared, but pretty much hectares, if I was just to briefly tell you right now, all right, 1 hectare literally means 10,000 meters squared, okay? It means 10,000 meters squared. So you can still see where you're still using the squared thing. And if you're dealing with volume, it is cubed. Millimeters cubed, centimeters cubed, meters cubed, kilometers cubed, okay? All right, so what measurement should she use if she wants to measure area? So if she wants to measure area, it should be something squared, right? So it should be square something. So the only one that's square something is this one here, square meters, okay? It can't be cubic, because cubic is how you measure volume. And then I told you that we're not measuring length or perimeter, so it can't be meters or centimeters, okay? So therefore, the answer must be square meters. And that makes sense. That really does make sense. Why does it make sense? Because if you think about it, you probably have, this is something like, I don't know, 20 meters. This is something like maybe, I don't know, 60, 80 meters. I'm not sure exactly what the length of a football field is, but you can see that we're dealing with meters and meters. So if you times meters and meters, you're going to get square meters, okay? All right, question 3. Marzia counted how many times each letter appeared in the sentence. Which column represents the letter I? Okay, so that's pretty straightforward. How many I's are there? Okay, how many I's are there? So we have 1, I'll use something smaller. We have 1 I, 2, 3, 4, 5. We have 5 I's. So you'll notice this says letter frequency. So which, and this says frequency of letter. So we want to see which letter has a frequency of 5. And there you go, there's something that's got a frequency of 5. So this must be the letter I. So the answer must be A. Okay, the answer must be A. That's the one that appears 5 times, okay? Just so you know, if I was to pick another letter, so for example, S, you can look, let's count the S's. 1, 2, 3. We have 3 S's, so then you can see that there is a particular letter that's got a frequency of 3, so there you go. B would be the letter S, just like this was the letter I. So that's how it works. This is basically a column graph demonstrating letter frequency, okay, the frequency of each letter. All right, how many lines of symmetry does this picture have? So symmetry means like it's a mirror image across that line, okay? Symmetry means like symmetrical. So I can see 2 clear lines of symmetry, 2 lines where we can see a mirror image. Here's 1 line of symmetry. So you can see that whatever's happening over here is the exact same as what's happening on the other side. So this is 1 line of symmetry. Alrighty, because it's symmetrical across there. Here's the other line of symmetry right here. There's a line of symmetry right there. So you can see that it's symmetrical across this line because whatever's happening over here, the same thing's happening over here. So the answer is definitely at least 2 or more, okay? We at least have 2 lines of symmetry. Are there any more? Are there any diagonal lines of symmetry? So if anyone tries to draw something like this, all right, if anyone tries to draw something like this, you'll realize it's not symmetrical across this, okay? It is not symmetrical across this because look, it looks funny. Basically, this looks like this, for example, and on the other side of the line, it looks like that. That doesn't count, okay? So that is not a line of symmetry. So we only have 2 proper lines of symmetry. So the answer is C. Okay, when Olivia weighs herself, the scale shows 58.2 kilos. She took off her jacket and now the scale shows 56.6 kilos. So what was the mass of her jacket? Okay, so that's straightforward. So she weighs 58.2 with the jacket, and without the jacket, she weighs 56.6. So that's a simple case of subtraction. 58.2 minus 56.6. And we should all know how to subtract by now. You can't do 2 take 6, so you borrow 1. So we're actually going to do now, if we borrow 1, it basically becomes 12. So 12 take 6 is 6. And then 7 take away 6 is 1. Notice I carry the decimal point. All the decimal points line up. And then that's it. 5 take 5, 0. So the jacket weighs 1.6 kilos. So that's B. A lift is designed to hold 13 people. Fine. The average person weighs 75 kilos. Okay. So what weight is the lift designed to hold? So I hope everyone realizes this is a case of multiplication. So we have 75 kilos and each person weighs 13. Now you can also do 13 times 75 if you want, or whatever you want to do. I just prefer to have the bigger number on the top, but it doesn't matter, okay? So 5 threes are 15, carry the 1. 7 threes are 21, plus 1 is 22. So that's 225. And then exact same way, we now have to do 75 times 1. So 5 times 1 is 5, and then 7. So there's your 75. Remember, you're meant to leave an empty space here, or you're meant to put a 0 here, whatever your school teaches you. And we add this all up. So that's 5, 2 plus 5 is 7, 9. Okay? You could have multiplied the other way around. So instead of doing 75 times 13, you can do 13 times 75. So first you have to do 13 times by the 5. So 3 times 5 is 65, carry the 6. 1 times 5 is 5, plus 6 is 11. So that's 1. Alternatively, then, you do 13 times 7. But before you do the 13 times 7, you copy the 0 down. 3 sevens are 21, carry the 2. 1 7 is 7, plus 2 is 9. Okay, sorry, 1 7 is, did I do that properly? 3 sevens are 21, carry the 2. 1 7 is 7, plus 2 is 9. That's perfect. Now what I didn't do properly is the top part. Okay, I made a silly mistake. Let's try again. 3 fives are 15, carry the 1. 3 fives are 15, carry the 1. 1 5 is a 5, plus 1 6. Okay, so that was my mistake. I didn't do 13 times 5 properly. You add them all up, and then you get 5, 7, 9. All right, always good to double check, or always good to do your question a different way. So the answer is 975 kilos. All right, what number is next in this pattern? Okay, can you guys see what the pattern is? All right, remember, you can always pause the video at any point in time, stop, and see if you can do the question by yourself. Ideally, you should be doing that at each question. Before I go through it, just pause the video and try and see if you can do it yourself. Alrighty, so which number is next in this pattern? So what is the pattern? 10 and then 3 next. So it looks to me like they've done like minus 7. And then 3 to 13, that's plus 10. 13 to 6 is minus 7. But then 6 to 10 is 16. There you go. I can notice the pattern. Notice what they're doing. Each time they're doing a minus 7 followed by a plus 10. Minus 7 followed by a plus 10. So 16 takes 7, 9, plus 10, 19. Okay, 19 takes 7, 12, 12 plus 10, 22. So let's see what's happening near the end. So you can see they're doing 15 plus 10. Then it's minus 7 again. So the next one must be plus 10 again, okay? That's the pattern. That was a pretty straightforward pattern, and that is the pattern. So we need to do 18 plus 10. Now, everyone should be able to do 18 plus 10 in their head. 18 plus 10 is clearly 28. So the answer is C. Good work. Question 8. Great. Remember, pause and do the question, and then play again and see if it's the same as what I said. Eva has 3 t-shirts and 3 skirts. How many different ways can she match a t-shirt and a skirt? All right. So guys, there is a long way and a quick way and a slow way to do this question. So the quick way is this. The quick way is to draw yourself these two basically like spaces or 2 slots. All right. And one slot is for the t-shirts. So this slot is for t-shirts. All right, T. And this slot is for the skirts. Okay, this lot is for the skirts. So the question is, how many different ways can she match a t-shirt and a skirt? So how many t-shirts can she wear, first of all? How many different t-shirts are there? There are 3 different t-shirts, so she can wear 3 different t-shirts. How many different skirts can she wear? In the same way, she can wear 3 different skirts, and then you multiply it together. Okay, that's the quick way of doing it. So 3 times 3 is 9. So the answer is B. Okay, that's the quick way of doing the question. Now, there is a long way of doing the question. So let's say we call this A, B, and C. And let's say we call the skirts 1, 2, and 3. Now remember, you can't wear 2 shirts. That doesn't make sense. Okay, and you can't wear 2 skirts. That also doesn't make sense. So how many ways can you could make a systematic list? So A can go with 1, A can go with 2, A can go with 3. So you can see that A can go, those are the different combinations of A. Then same thing with B. B can go with 1, B can go with 2, B can go with 3. C can go with 1, C can go with 2, C can go with 3. So there you go. You can clearly see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 different combinations that she can have. Okay? Cool. Question 9. Pause. Try yourself first. Okay? I shouldn't have to remind you each time. Pause. Try yourself first. Then see if you get the same answer as me. Chris bought 5 identical packets of biscuits. She opened 1 packet. Okay, so she bought 5 identical packets. I'll highlight that. She bought 5 identical packets. She opened 1 packet, and ate 3 biscuits. All right, but she still had 82 biscuits left. Which expression shows how to work out the number of biscuits that are in a complete packet? Okay, now we have 82 biscuits left, but that's because she ate 3. So before she ate the 3 biscuits, she actually had 82 plus 3. I hope everyone realizes she had 82 plus 3 biscuits before she ate the biscuits. Before she got, I keep saying she. Oh yeah, Chris, I guess it's a boy or a girl's name. So before she ate 3. All right, so she had 85 biscuits. But the question wants to know how many biscuits were in each pack. And remember, she had 5 identical packs. All right, so we know she had 82 biscuits left. If you add 3, that will tell you how many biscuits she had left before she ate some. So then if I want to know how many biscuits are in each pack, I divide this entire thing by 5. So then I need to put it in brackets and then write divide by 5, okay? If I wrote this, it would be wrong. If I had 82 plus 3 and I wrote divide by 5 straight away without the brackets, this is wrong because according to BIMDAS, we do the division first. In BIMDAS, division comes first. And that's clearly what we clearly don't have the division first. That's clearly not what we have. We clearly have the plus 3. So this would be wrong. This would be the wrong way of doing it. This would be the correct way of doing it, having the 82 plus 3 in brackets. So the answer is therefore A. A is the answer. And we don't even need to figure out how many biscuits she had. It just says what's the correct expression for working out the number of biscuits in each packet. Question 10. Uma walks to school each day. She walks 2 kilometers from her house to the school gate. And then she walks another 23 meters. How far does she walk to get from her house to her classroom? So she obviously walks 2 kilometers first. Well done. And then walks another 23 meters. Now, we can't be adding kilometers and meters. That doesn't make sense. It's just like you can't add apples and oranges. You can't add kilometers and meters. You can see that all of the answer is in meters. All the options are in meters. So that's all we're going to do is convert everything into meters. So 2 kilometers basically means 2,000 meters plus 23 meters. And 2,000 plus 23 is basically 2,023. Okay, that's easy. So the answer is D. Question 11. This table shows a pattern of numbers. What should the question mark be? All right, so how do you get from 4 to 16? You'll notice that they've done, basically, you can think of it as, first of all, someone might think that, okay, 4 plus 12 gives you 16. 6 plus 30 gives you 36. 8 plus 56 gives you 64. There's no pattern here. There's no pattern in the plussing of things. So it's not a plus something that's the pattern, okay? It's not a plus something that's the pattern. So you'll notice that 4 times by itself gives you 16. 6 times 6 itself gives you 36. 8 times 8 gives you 36. You can see they're basically timesing it by itself, or you can think of it as squaring it. They're basically doing 4 squared. 4 squared gives you 16. 6 squared gives you 36. 8 squared gives you 64. 10 squared gives you 100. So you'll notice it's like a squaring thing. Perfect. What else though? How do I know what number goes here? Because there's 2 question marks. Now there's a pattern. You can see it's even numbers. It's like 4, 6, 8, 10. These are even numbers. This one you can see there's a plus 2, plus 2, plus 2 pattern. So if we add plus 2, another plus 2 would make this a 12. And then 12 squared, or you can think of it as 12 times 12, will give you 144. So the answer is D. Okay, there were 2 patterns. One is the patterns within each column, and then there was a pattern within the row itself where we kept adding 2. All right, 12. The table shows the maximum temperature in 5 cities for one particular day. Which city's maximum temperature is 12 degrees colder than Athens? Now, colder means less than Athens. Yeah, hotter means more and colder means less. So we want something that is 12 degrees colder than Athens. Now, Athens is already 8 degrees. So we need to do 8 take 12. Now, I hope you guys understand your negative numbers by now. But if not, I use the dollars way of thinking about it. So if you have $8, and then you minus away $12. Now, obviously, you have negative dollars now. So 8 take away 12, you'll have negative $4. You'll have negative $4. Which of these is negative 4? The answer is Dublin. Dublin has negative $4. So the answer is B. All right, 13. City and Rand recorded the amount of exercise they did in 1 week. All right, Cindy and Rand recorded the amount of exercise they did in 1 week. Cindy exercised for 14 hours and 12 minutes. Rand exercised for 12 hours and 41 minutes. How much more did Cindy do? So this is a case of subtraction, but it's a different kind of subtraction. Think about it. We have 14 hours. I'm even going to write it down. 14 hours and 21 minutes. Oh, sorry, 12 minutes. She did 14 hours and 12 minutes. So we have 14 hours and 12 minutes for Cindy. And Rand has 12 hours and 41 minutes. That's what he has. And it's asking how much longer did Cindy exercise. So this is a subtraction, but it's a different kind of subtraction, okay? So first of all, I need to do 12 minutes take away 41 minutes. I need to do 12 minutes take away 41 minutes. Now you can't do that. So what I'm going to do is I'm going to borrow an hour. So instead of 14 hours, we have 13 hours. But if I borrow an hour, I get an extra 60 minutes. All right, I don't get an extra 10 minutes. I get an extra 60 minutes. So we don't write 22. That's not how it works. If you borrow an hour, you don't get 10 minutes. You get an extra 60 minutes. So 12 plus 60 is 72 minutes. We now have ourselves 72 minutes. And now let's do the subtraction. So 72 take 41, so 2 take 1 is 1. And 7 take 4 is 3. So that's 31 minutes. So I did 2 take 1 is 1, and 7 take 4 is 3. And 13 hours, take away 12 hours, is 1 hour. So the answer is 1 hour and 31 minutes. So the answer is B, okay? The answer is B. That's a very nice concept of subtraction, but that's subtraction with hours and minutes instead of subtraction using like a metric system of tens and hundreds and thousands, okay? That's a nice question. You might want to revisit that one, okay? Cool. Question 14. What is the value of 7 squared plus 5 squared? All right, so 7 squared. Everyone should know squared means times by itself. So you don't need to write this line of working, but 7 squared means 7 times 7. And 5 squared means 5 times 5. And everyone should know BIMDAS, okay? So it's BIMDAS. So You can think of it as the fact that you need to do the indices first. Indices means power. You need to do the indices first. Or you can think of it as that you need to do the timesing first, okay? Because multiplication comes before addition. So then next is addition. So what is 7 times 7? 49. Okay, 7 times 7 is 49. What about 5 times 5? That is 25. So we have 49 plus 25. That gives you 74. If you need to do that on the side, it's okay. So we have 49 plus 25. 9 plus 5, 14. Carry the 1. And then 1 plus 4 is 5, plus 2 is 7. That's 74 as well. Okay, so the answer is C. The answer is C. Nice. Next question. The diagram shows the points 1, 4, 5, 4, 5, 8 on a grid. So I hope everyone knows how these work. You always give the x value first and then the y value. This here is the x-axis and always the vertical one is the y-axis. So you can see that this one is 1 unit to the right and 4 units up. So this is the point 1, 4. That's the point 1, 4. This one you can see is 5 units to the right and 4 units up. So this is the point 5, 4. And then this here is 5 units to the right and 8 units up. So this here is 5, 8. Okay, great. So Manling drew another point which was an equal distance from each of the other 3 points. Okay, so guys, what point along this Cartesian plane, along this xy axis, okay, Cartesian plane basically means xy axis, what point along this xy plane is equal distance from the other 3 points? Which point is equal distance from the other 3 points? All right, and you can clearly see, everyone should realize it is this point right here. You can see that this distance, that distance, and that distance are the same if we're talking about with respect to that one point. That's like in between all of them. You can't put it here because then it might be equal distance from those two, but now we're so far away from that one. So you'll notice that that's like 2 diagonal squares. This is 2 diagonal squares. This is 2 diagonal squares. And remember, you always give the x value first. Always the x value followed by the y value. So what's the x value? The x value is this. That's 1, 2, 3. So the x value is 3. And the y value is 1, 2, 3, 4, 5, 6. You can see it even lines up with 6. So it is 3, 6. X value first, then the y value. I'll say that again. We went 3 units to the right, and then we went 6 units up. So it is 3, 6. So not 6, 3, but 3, 6. Okay? 6, 3 is like here. 6, 3 is there, and that was not the answer. We didn't go 6 across and 3 up. We went 3 across and 6 up. Okay? Next, Brett made a design on a computer. Fine. He then rotated the design. After the rotation, it looks the exact same. How many degrees did Brett rotate the shape? Alrighty. Now you guys can see, it's a slightly tricky question, but you can imagine, in fact, the best way for me to do it is first for you to realize that he then rotated and it looks the same. I think the best thing for you to realize is that it's a triangle. All right, it is a triangle and it's a completely symmetrical triangle. All right, it's equilateral. You can see that's a red, red, red. Then there's like green here and green there and green there. Just to give you like a brief way of showing it. I won't do the whole thing, but I'll just show you briefly. All right, I'll show you briefly that this is what we have. And he's got like, if I was to do like dot to represent the red, he's got red, red. Then he's got like green, 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 green. So like green like that, green here, green here, green here. I don't want to do them all, but I'm just trying to show a point. And then you have red and another red and red's here, for example, one red there. I'm not going to do them all, but you can see that's the shape that he has. All right, and guys, it's a triangle. So we all know that definitely, we forget what shape it is. Anything, if you rotate it 360 degrees, it will be the same. If you rotate anything 360 degrees, it will definitely be the same. And you can see that none of the options say 360. So you got to realize that a triangle has got three sides, and if it's a completely symmetrical triangle, I want everyone to realize that means that if you rotate it 120 degrees 3 times, all right, it will still look the same. All right, if you rotate it 120 degrees 3 times, it will look the same. All right, in fact, not just rotating it 3 times, even if you rotate it just 120 degrees, that's, how did I get the 120 degrees? I just did 360 divided by 3. I hope everyone realizes 360 divided by 3 is like 120, because 36 divided by 3 is 12. So 360 divided by 3 is 120. So watch how this works. If I've got this and I rotate it, if I do a 1/3 of a rotation, which means 120 degrees. So watch, I'll do, so you can see it doesn't look the same, I'm going to do 1/3 of a rotation, okay? 1/3 of a rotation, so it looks kind of like this. And then let's just move it on the picture. So we'll move it back to on the picture, and whoops, it became a bit small because it resized. So let me just make it big again. There you go. That's what happens if I rotate it 120 degrees. And what do you guys notice? You'll notice that it's the exact same. It looks exactly the same. The greens still line up. So that's before the rotation, and this is after the rotation, okay? And you can see that it's lined up exactly the same. I'll rotate it back if you want to confirm it. So I'll rotate it back. So let's rotate it back. I can't remember which way I rotated it, but doesn't matter. You can see that every 120 degrees, every 1/3 of a turn, there you go. That's, so this is where I am, okay? Right now I'm right here. You can see that the dots line up. I'm going to rotate it 120 degrees, which is 1/3 of 360 degrees, all right? And I know it's moved. Let me just put it to the right spot. And you'll notice that it's the exact same. The greens line up, the green line up, the red line up. So this is proving that 120 degrees rotation, and it still stays the same, okay? And the way that I got 120 degrees is we all know that when you rotate something 360, if you do a 360, you're basically facing the same way. So all I did was I did 360, but then I divided it by 3. So the answer is B. Question 17. A perfect number is a number that's equal to the sum of all of its factors except for itself. Okay, so you'll notice, guys, the factors of 6 are 1, 2, and 3. Now, technically, another factor of 6 is also 6, but it says we have to add up. Read the question. A perfect number is a number that is equal to the sum of all of its factors except for itself. Except for itself. Which of these is a perfect number? So let's try the options. What are the factors of 20? The factors of 20 are 1, 2, not 3, 4 is, 5 is, 6 isn't, 7 isn't, 8 doesn't go into 20, 9 doesn't go into 20, 10 does go into 20. And then we don't include 20 itself because it says except for itself. So now let's add these up. 1 plus 2 plus 4 plus 5 plus 10. What do we get? 1 plus 2 is 3. 3 plus 4 is 7. 7 plus 5 is 12. 12 plus 10 is 22. Oh, that doesn't work. That's not a perfect number because we want a number where it adds up to the sum of its factors. Okay, so it's not 20. Let's try 24. So 24, what goes into 24? 1 goes into it. 2 goes into it. 3 goes into it. 4 goes into it. 5 doesn't. 6 goes into 24. 8 goes into 24. All right, you can see there's not going to be the answer. There's too many numbers that go into 24. This is too big. All right, and then 12 even went into 24. This is so big. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 6 is 16, plus 8 is 24, plus 12 is 36. You can see it went way too big, so it's not that. Let's try 26. What numbers go into 26? Now 1 goes into it. 2 goes into it. 3 doesn't, because you can think about it. 26 adds up to, the digits add up to 8. So 8's not divisible by 3. So 26 doesn't go, 3 doesn't go into 26. 4 doesn't, because think about it. 4 goes into 24, 4 goes into 28, but 4 doesn't go into 26, okay? So it's not 4, it's not 5, it's not 6. Oh, there's very little. Not 7, not 8, not 9. Pretty much the next number is 13, okay? That's like halfway number. This is possibly too little. 1 plus 2 is 3. 3 plus 13 is 16. Okay, so the answer is not C. It must be D. It must be D. And let's check and make sure we didn't make a silly mistake. So what are the factors of 28 other than itself? 1 is, 2 is, 3 isn't, still doesn't divide by 3, because think about it, 2 plus 8 adds up to 10. 10 is not divisible by 3. 4 is, 5 isn't, 6 isn't, 7 is, 7 goes into it. 8, 9, 10 doesn't, 11 doesn't, 12 doesn't, 13 doesn't, 14 does. All right, and by the way, do you guys notice it happens always in, you'll notice there's always pairs. So 2 times 14, 28. 4 times 7, 28. Technically, even 1 times 28, 28. So all of them would have been in pairs. All right, same thing over here. You can see 4 6s. So this is a matching pair. 4 6s, 24. 3 8s, 24. 2 times 12, 24. And there would have been 1 times 24. But remember, we didn't include itself. So they're in pairs. So there's your pairs. What do they add up to? 1 plus 2 is 3. 3 plus 4, 7. 7 plus 7, 14. And perfect, 14 plus 14 is 28. So the answer is definitely D. Okay? All right, question 18. This pattern is based on rotation. What comes next in this pattern? So the easiest thing to do, guys, is look at the missing square. So you can see the missing square used to be here, that corner. Then they put it in this corner. Then they put it in that back corner. So you can see it's rotating. It's rotated from there. That's what's happened. It's gone from here to here. So it's basically rotated along that line. Then it's gone from there to there. So it's gone along this line. Then it's going to go from here to here. So it's rotated along that line. So you can see they keep rotating at 90 degrees each time. Each time they're rotating it. So actually, and now it's gone. They've gone from here to here to here to here. So now what type of rotation do they do now? You'll notice it goes from there to there. So they've effectively rotated it down. So before they were rotating it up along here. So just so you guys can see the rotations, first they rotated along here to give you, once they rotated along here, that gave you that shape. That's where the missing block was. Then they rotated along here. So the missing block was there. Then they rotated it from here to here, so that means they rotated along this line here. And then the next one, rather than rotating along that line, the missing square is not there. You can see the missing blocks here, so they've actually rotated it down to here. So down, and then from here, the missing block has gone there, and then it's gone there. So you'll notice that they've rotated it. So basically 1, 2, 3, and then they rotated it down 1. And now again, they're rotating it here. And then they rotate it there. All right. And then they rotate it along that line that we can't see, that behind line. Okay. So that's what they've got so far. Okay. So you'll notice that that's 3 rotations already. Okay. So that's 3. So they did 3 rotations along 1, 2, 3 before they changed the face along which it was rotating. So then it was 1, 2, 1. Okay, 1 to change the direction of rotation, and then again 1, 2, 3. So I hope you guys realize that which one was the odd one out. The odd one out of all of these rotations, you can see that all of these other rotations were flat. This was a flat rotation, this was a flat rotation, only this one was a vertical rotation. So after 3 rotations, we got ourselves a vertical rotation. So this one here is the vertical rotation. Every 3, there appears to be a vertical rotation. So we do 3, a vertical rotation. 3, so now we need to do ourselves another vertical rotation. We need to do ourselves another vertical rotation. So you can clearly see that right now, the missing piece is right here. That's where the missing piece is right there. So if I do a vertical rotation, the missing piece would be back to being up. Okay, so the answer is C. All right, that's a tricky one. That is a very tricky one. All right, I thought that's quite a challenging question. All right, now some people might have even selected A. All right, I can tell you that the marking key in some questions, there are two possible answers. I would have accepted anyone that wrote A as well. A would have been acceptable. Why would it have been acceptable? Because you don't know what was here. We don't know whether for sure there are 3 squares before you get a vertical rotation. Do you get what I mean? What if the square before here there was another rotation, like another horizontal rotation? We don't know for a fact that there were 3 horizontal rotations before the vertical rotation. So what I'm trying to say is the marking key would have also accepted A. And why would it accept A? Because look, maybe there was like 4 horizontal rotations. So what I mean by that is, first it did this. You can notice that it's going to go from here. So the missing block is going to go from there to there as it rotates along here. So it rotates. So if I was to just do the missing blocks for you, if I rub out the red so that you don't get confused, you can see it's gone from there to there to there. So now the missing block should be like behind. And if the missing block's behind, we should be able to see a perfect square. So another answer that I'm going to accept for question number 18 is A. So I'll accept the answer 18, which is A. A is if you continue doing another horizontal rotation, and C is if you do a vertical rotation. And if you do a vertical rotation back up, we already went down. So if you go back up, the missing square will go from down to being on top again. So that's why C could have been the other answer. Okay? Great. All right, question 19. The map shows 4 towns. Which table matches the distance in kilometers between the towns on the map? We want the distance between the towns on the map. And you'll notice they've given you a scale, so you need a ruler, okay? You'll need yourself somewhat of a ruler to check the scale. Now, I'll do it roughly, but you, again, use a ruler. And I am sure that when you guys have it printed out, you can, right now I can zoom in and out, and that makes it confusing, but you guys can't zoom in and out on a hard piece of paper. So why don't you guys try and match what the distance might be? So you can see that this here is 10 kilometers. This here counts as being 10 kilometers. So how far away are Safton? And remember, we go from the middle to the middle, okay? It makes sense to go from the middle to the middle. So you can clearly see that this distance looks similar to that. Technically, it's a bit diagonally, but it's pretty much the same distance. So what I'm trying to say is the distance from Samton to Ifaka is 10. The distance from Samton to Ifaka is definitely 10. So we're looking for any option where they say Samton to Ifaka is 10. So this one says 10, this one says 10, this one says 10. So then but this one says 20. That's not correct. So we can eliminate 20 as being an answer. All right. What about the distance? Remember, you have a ruler, so that might help. What about the distance from here to here? So again, I don't have a ruler right now, so it's a bit tricky. But if I think about it, I want to break it up into lots of these, right? So that looks like, that looks roughly like this. Yes, it does. Again, having a ruler really helps. All right, so that's that. And then another one, actually probably a bit bigger. This is bigger, right? So then we have 110 there and another 10 there. That seems to match. Yep, that seems a bit more accurate, okay? So again, with a ruler, it would be more accurate, but you can see we have 2 of these. So what I'm trying to say is this looks like 20, all right? At least close to 20. You can see everything's whole numbers anyway, okay? So the distance from Samton to Mudgate is 20. So this says 20. Samton to Mudgate, it says 20. This one says Samton to Mudgate is 10. That's definitely wrong. That's clearly not 10, guys. That's so wrong. So Samton to Mudgate, 10, wrong. And this one also says Samton to Mudgate, 10, wrong. So you already have the answer. All right, you have to be sensible in these. If you've already eliminated all the options, if it's a multiple choice question and you've eliminated all the other wrong options, it has to be that. Okay, so the answer is A. And then you can cross-check. You can see Samton to Forwong, that's really big. Yeah, Samton to Forwong, that's like 1 there, another one, another one, another one. So yes, it does look like it's about 4, so 40 kilometers. All right, so you can see it all seems to match. Ifaka to Forwong is 30. Ifaka to Forwong, yeah, this looks about 30. That's like 1. That's another one. That's another one. So Ifaka to Forwong, 30. I'm not going to do them all, okay? But you can clearly see that A is correct, and there's no reason to do them all. You won't finish your test or exam in time if you're trying to do all of them, okay? So sometimes if you eliminated the wrong answers, it just makes sense to then go with the remaining answer. All right. How many multiples of 21 are there between 200 and 400? Now, guys, they really should say inclusive or exclusive. So how many numbers are there between 200 and 400? Now, if they don't say inclusive or exclusive, it generally means exclusive, okay? It generally means exclusive. So we want to know the multiples of 21 between 200 and 400 exclusive. Now, what if they don't write exclusive? If they use the word between and they don't write the word exclusive, I want you to assume it means exclusive, which means not including the 200 and the 400. Now, having said that, 200 and 400 aren't multiples of 21. So whether they use the word inclusive, exclusive, or inclusive, or they don't, it really doesn't make a difference because the numbers themselves are not multiples of 200 or 400. So let's have a look. Now, you're meant to just think that what's the multiple of 21 that's somewhere more than 200? And the common one, the easy one to realize is it's 210. 210 is definitely a multiple of 21. There is no doubt about it that 210 is a multiple of 21. That's 21 times 10. Alrighty. So don't need to count them all. You need to be smart. You need to be smart. So what I mean by that is 21 times 10 is 210. All right, obviously 21 times 9 is not going to be a multiple of 400. You can see 21 times 9. So 1 9's a 9, 2 9's are 18. So 189. 21 times 9 is 189. So 189 is not a multiple of 21 that's between 200 and 400, okay? Do you guys realize another one that's not going to be a multiple of 21 between those is 21 times 20. If 21 times 10 is 210, 21 times 20, well, first we do 21 times 2, which is 42, and 0. And do you guys realize that's too big as well? All right, it needs to be between 200 and 400. It needs to be between 200 and 400. So obviously 210 is between 200 and 400, but you'll notice that 189 and 420 are just outside. So you'll notice that 21 times 10 fits. 21 times 9 doesn't fit. It's outside the required numbers. 21 times 10 does fit. 21 times 20 does not fit. But I hope you guys realize that 21 times 19 will fit. I'm very confident that 21 times 19 will fit because 420, 21 less than 420 should fit, okay? And I'll prove it to you. 21 times 19. So first we do 21 times 9. So 1 9's are 9 and 2 9's are 18. So that's that. And then we do 21 times 1. And then when we do 21 times 1, we have this. Remember not to forget to put the 0 there. 9, 8 plus 1's 9, 399. You can see it just fits, okay? So definitely, we have these numbers that fit. We want to know, these are all multiples of 21. We want to know how many multiples of 21 are going to fit between 200 and 400. So you can see 21 times 10 fits, then 21 times 11, 21 times 12, 13, 14, 15. You can see that 21 times all of these should fit, because if 21 times 19 fits, all the way up to 21 times 15 should fit. 16, 17, 18. There you go. All these numbers here will fit. So how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of them fit. 10 numbers fit. So the answer is 21 or 10 numbers. The answer is B. There are 10 multiples of 21. Again, I'll do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 multiples of 21 that will fit, and you'll notice I didn't have to work out all of them. I just had to work out the first one and work out the last one. And then since I knew 21 times 10 fits, and I knew 21 times 19 fits, then all these other versions of 21 lots of those would also have fit. Okay? Nice question. A bit tricky, but a nice question. All right. Ivan has got 2 cubes made of the same substance. Fine. The small cube has a mass of 13 grams. The small cube has a mass of 13 grams. All right, the height of the large cube is 3 times the small cube. What is the mass of the large cube? So this, guys, has got 3 times the dimensions of this. It says the height is 3 times as much, and because it's a cube, all the sides are the same. So if this one, the sides are x, x, and x, then this one would be 3x, 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 okay? Because it's a cube. What's the mass of the large cube? Now, if anybody does 13 times 3, if anybody thinks that this is 3 times as big, 13 times 3, 3 3s are 9, 1 3 is a 3. If anyone does and writes 39 grams, that is not correct. 39 grams is wrong. Because think about it, guys. It's a cube. Think about it. There's more than 3 small cubes in this. Would you rather have 3 golds of bar that look like this, or would you rather have 1 gold of bar that looks like this? Obviously, 1 gold of bar that looks like this. This one's huge, and I'll prove it to you. I'll show you how huge it really is. I'll help you interpret it. So actually, first let me just label these sides. It just makes it a bit easier to see what I'm trying to show. Alrighty, so. Alright, so if you think about it, that's what we have. I'm just trying to make it easy to see. So you'll have this, and remember, it's not to scale, okay? It's not to scale, but they did say that this is 3 times bigger than this. So I'm splitting it up into lots of 3. So there's 1 lot of 3 here. And, all right, it's not to scale, so it's just a little bit confusing to see, but I hope you guys can visualize this, or I'm basically drawing it out, so you don't even have to visualize it. All right, so all these are meant to be the same. You'll notice that. And then over here, I can also break it up there. So it's something like this. Okay, so that, and then here as well. And then here as well. You can see, all right, it's a lot of effort, so you don't have to, I'm just trying to make you guys realize this. You don't have to draw it out. This is just to help everybody in the class visualize. We have this, and we have this, and then it just keeps going. So what I'm trying to say is this, that each of these blocks, for example, this block right here is as big as this one. So how many of these blocks do we have? You'll notice there's 3 this way, 3 that way, and 3 that way. So you actually have, if this is 1 block, if this here is just 1 block, this is actually a 3 by 3 by 3. This is actually 23 by 3 by 3 is actually 27 blocks. So if this is 1 block, this will be 27 blocks. So there's a lot of blocks in that one, okay? There are lots and lots of blocks. Not 3 times as many blocks, not 9 times as many blocks, but there are actually 27 times as many blocks in this second shape. So if this first block weighs 13 grams, the next one is not going to weigh 39. You don't times it by 3. That would be wrong. We actually have to times it by 27. All right, and this is going to be a big number, 13 times 27. So 3 7s are 21, carry the 2. Guys, a smart student will realize it's more than 39. A smart student realizes it's more than 39, and a smart student will realize, well, 3 times 7 ends with 1, so the answer must end with 1, so the answer must be D. So that's what I mean. Sometimes you don't have to do the entire question. It's not about doing the entire question every single time. If it's a multiple choice, think about it. If your GATE test has multiple choice and you have already eliminated all the options, if you've eliminated all the options, there is no need to do every single, like the question fully. In school, you might need to show full working out, but not for a GATE test necessarily. So 3 7s are 21, carry the 2, 1 7 is 7, plus 2 is 9, and then carry the 0. Then 3 2s are 6, and 1 times 2 is 2. So we have 260. If we add this all up, what do we have? So 1 plus 0 is 1. 9 plus 6 is 15. 1 plus 2 is 3. There you go, 351. But we already knew the answer was 351 because of elimination of the other options. All right, question 22. Each shape in this pattern uses orange and white tiles. Which rule gives the number of white tiles in relation to the orange tiles? Okay, we need a rule. We need a rule for the number of white tiles in relation to the number of orange tiles. The number of white tiles in relation to the number of orange tiles. So let's just draw ourselves up a little table. And in this table, this is what I mean about being systematic. We have to be systematic. So we want to know the number of white tiles in terms of the orange tiles. All right, so it has to be in terms of the orange tiles, the number of white tiles. So let's write down how many orange tiles here. 1, 2, 3 orange tiles. And the number of white tiles is 1, 2, 3, 4. All right, what about here? There's 1, 2, 3, 4, 5, 6, 7, 8 white tiles. And then you can see there's 1, 2, 3, 4, 5 orange tiles. All right, what about the next one? 1, 2, 3, 4, 5, 6, 7. 7 orange tiles. And how many are white? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, and lucky last, we have how many orange tiles? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 orange tiles. And in terms of white, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. So what is the pattern? So you can even try the rules, okay? You don't have to work it out. You can try the rules. Orange tiles, take 1 times by 2. Let's have a look. Orange tiles, so that's 3. Take 1, so 3 take 1 is 2. Times 2 is 4. That seems correct because that's what it said, times 2. Let's check another one. 5, what do we have to do? Orange tiles take 1, so 5 take 1 is 4. 4 times 2 is 8. 7 take 1 is 6. 6 times 2 is 12. This rule seems to be working. So we do orange tiles take away 1 and then times it by 2. Doesn't matter whether you write the times 2 at the start or whether you write the times 2 at the end. As long as the 7 take 1 is in brackets, it's fine. So 9 take 2 is, 9 take 1 is 8. And then 8 times 2 is 16. So there's your rules. It's the orange tiles, take away 1, times by 2. So there you go. I use the options to help me figure out what it is. All right, you can't do this, guys. If you do orange tiles take 1 times 2 and you don't put it in brackets, then according to BIMDAS, you do the times 2 first. And that's not what it is. We're not doing the times by 2 first. We're doing the orange tiles take away 1 first, and then we are timesing by 2. So that's why the answer must be A, okay? Has to be, you have to do orange tiles take away 1 first. All right, and there's only one option that's got orange tiles take away 1 in brackets first. There's only one option that says orange tiles take 1 first. And that's what I had to do each time I was subtracting 1 away first. Okay? Alrighty, question 23. A teacher wishes to store folders upright in a bookcase. Each folder is 7 centimeters wide. Fine. Alright, each folder is 7 centimeters wide. The bookshelf has 3 shelves, and each shelf is 1.3 meters. Alright, how many folders can she store in each bookcase? Now remember, guys, you can't cut up the folders. Alright, you can't cut up the folders. So what you have to first ask yourself is that each shelf is 1.3 meters, and that each folder is 7 centimeters wide. So how many folders can we put in each shelf? All right, and remember, you can't cut the folders up. That's not allowed. So first we need to do 1.3 meters divided by 7 centimeters. And it's too hard to do that. You need everything in the same units. So first we need to do 130 centimeters divided by 7 centimeters. How many times can you put 7 into 130? How many times can you put how many folders can you put in one shelf? So let's have a look, guys. What's close? I don't think 7 goes into 130 exact. All right, but we can get close. First, let's do 130 divided by 7. So how many times 7 goes into 130? It's a bit hard to do the division because 130 divided by 7, you straight away have to, well, actually, it's still doable. Let's do it. 130 divided by 7. So if I do 130 divided by 7, alrighty, 130 divided by 7. Alrighty, so how many times 7 goes into 13? So 1 times 7, that's 7. We minus it away. 13 times 7, 6, 6, 0. How many times 7 go into 60? Well, 8 sevens are 56. So 8 sevens are 56, and then we have a remainder of 4. There it goes. So you know for a fact that you can definitely have 18 folders in each shelf. But remember, you have 3 shelves to work with. You have 3 shelves to work with. So the answer is actually going to be 18 times 3 because we have 3 shelves to work with and we want to know how many she can put in the entire bookcase. 8 threes are 24, carry the 2. 1 3 is a 3, plus 2 is 5. So she can actually put 54 book folders in her bookcase if we're not allowed to cut folders up, which is what we're going to assume. So the answer is B. All right, well done. We'll complete the remaining questions. So we're halfway. We'll complete the remaining questions in next week's video. Well done.